Hi everybody, this is Eduardo Suarez. This video is going to be a 2-for-1. We're going to continue where we left on my previous video. On my previous video, I showed you that there are three possible configurations for the 2D multi-view vision process. We have the fixed frame offset with a fixed camera. We have the fixed frame offset with a raw mounted camera. And we have the tool offset with a fixed camera. And here are some of the examples for the layout. This is a layout for the fixed frame offset with a fixed camera. We have two cameras looking at two different points on the part. We're going to have a calibration grid frame and an offset frame that both are going to be user frames. Then here we have the example for the layout on the case of a fixed frame offset with a raw mounted camera. In this case, we have only one camera, and the robot is going to move to two different points. That's going to be camera view 1 and camera view 2. iRVision is going to know the position of the camera because it knows the position of the camera relative to the robot, and it knows the position of the robot relative to the application user frame. Again, we're going to have a calibration grid frame and an offset frame that both are going to be user frames. And finally, we have the example for the layout for the tool offset with the two fixed cameras. Here, each one of the cameras is going to look at one of the camera view. We're going to have camera 1 looking at camera view 1 and camera 2 looking at camera view 2. In this case, a calibration grid frame and the offset frame, both are going to be tool frames. Also, the configuration can be used with one camera, as in shown in this example, where the robot is moving to one camera view, and then it's going to move to the second camera view. The main difference with this configuration is that it's going to take more cycle time to complete the camera process. Since we saw already the first configuration for the fixed frame offset with a fixed camera, today I'm going to show you how to set up the two configurations that are still pending: the fixed frame offset with the raw mounted camera and the tool offset with a fixed camera. Let's start by looking at the fixed frame offset with a raw mounted camera. I'm going to go very quickly with this configuration since it doesn't vary too much from what we have done so far. We're going to take the work cell that we already built on the previous video, and I'm going to rename it, and we're going to delete some of the features that we don't need. This is going to be my new work cell configuration. I removed the camera from the sensor unit that we have in here, and I installed the camera on the user tool number 1. If we open up the tool number 1, you're going to see the camera over here. So now what I've done, if we go to the vision, and we're not using the multiplexer anymore, I just have the camera 1 on the port 1. We're going to look at the user frames that we have. We have a user frame number 1. That's going to be our pickup position on the pallet. We're going to have the user frame number 2. That's going to be the place position on the conveyor. And still we have the user frame number 3. That is our calibration grid frame. I'm going to show you in a moment how the calibration grid frame was done in this case. And also we're going to have a user tool. That's going to be user tool number 1. That is going to be our gripper for picking up the part. So we have the user tool and user frame. I'm going to show you how I did the calibration grid frame. For that, first we're going to make visible the calibration grid in the two positions that we have in here. That's going to be for the camera view 1 and the camera view 2. I have the calibration grid visible. What I want to do, we're going to open the teach pendant. We're going to go to menu. We're going to select iRVision. We're going to go to Vision Utilities. And we're going to select Automatic Grid Frame Setting. We're going to go to Details. And in here for robot group number, we're going to select number 1. For the user frame or user tool, we're going to select user frame. user frame number, we're going to select number 3. For camera name, we're going to select the only camera that we have in the work cell. For the start position, we're going to select the position that we are right now, and for that I have a position register. So we're going to select the data. We're going to go to position register in here. We're going to make sure that we are on the tool number 1 and user number 0, and my camera position is going to be the position register number 2. That's going to be camera view number 1, position number 1. If we move to that position, we are already there. And also I have in camera view 1, position 2, that's going to be 100 millimeters higher than the position 1. If we look at this position, we have the Z, that's going to be 106 millimeters, and if we look at the position for the position 2, we're gonna be only at 6.7 millimeters on the Z axis. So what we're gonna do, we're gonna record this position, and one thing that we have to keep in mind, since in this case we have only one camera, we do only one calibration grid frame setting. So we're gonna record this position with shift record, and then we're gonna go to the next step, number 7. That's gonna be the grid spacing. In our case, we have 50 millimeters. And now we're gonna press shift and execute. I'm not gonna execute the process, I'm gonna just show you the result. So when this is done, we can go back to the user frame. So now we can select the setup frames, and we can go to user frames, and on user frame number 3, we're gonna have the user frame for the calibration grid frame. We can go to details, and this is going to be the result. Now we can compare the result with the one from the previous video. On the previous video, we used the 4-point method for the user frame on the calibration grid frame setting. So now if we look at the details, you can see that the result is very similar. So that means I did a very good job on teaching up the points. What we're going to do now, we're going to go to the iRVision. So we're going to select robot. We're going to go to Internet Explorer. We're going to select iRVision, Vision Setup, and here I have my camera data. I'm going to go very quickly with this. This is exactly the same we have been doing in the previous videos, so I just want to show you the results. We're going to select the camera 1. We're going to go to Edit, and for camera setup, we're going to select the camera. This is the only camera that we have in our work cell. The robot mounted camera, we're going to select yes. For robot holding the camera, it's going to be this robot on group 1, and it's going to be on the last axis. For calibration, we're going to select grid pattern calibration. On calibration setup, we're going to select the application frame. This is going to be the user frame number 0. The grid spacing is going to be 50 millimeters. For robot held calibration grid, we're going to select none. And for setting calibration grid position method, we're going to select use frame. On calibration grid location, for calibration grid frame, we're going to select the user frame number 3. That is our calibration grid for camera 1. And at this point, we can take a snapshot and we can press set. That's going to give us the position of the calibration grid related to the application user frame. Again, since we have only one camera, we're doing only one camera data. We're going to select calibration, the number of planes, we're going to select 2, and we're going to find the first plane. So with the robot in the position that we have right now, we're going to check the position for that. We're in the position number 1. We're going to select the snap, and we're going to press find 1. and it's going to find the plane number 1. Next, we're going to move to the second position. We're going to take the teach pendant. We're going to select the position register number 3, and we're going to move to that location. That's going to be 100 millimeters closer than the point that we had before. So at this point, we're going to go back again to the iRVision. We're going to take another snapshot, and we're going to find the second plane. So now we're going to get the calibration points, and then we need to review the error that we have for the plane number 1 and also for the plane number 2. And finally, the calibration result is going to give you the position of the camera relative to the calibration grid, the position of the calibration grid relative to the application user frame, and the position of the robot holding the camera. We can save the result and we can end the edit. Before we do the 2D multi-view vision process, we're going to remove the calibration grid from the part. Notice that the calibration grid is in the same height as the part. So when we go to the setup, we're going to put a 0 for the Z position of the part. And we're going to move the robot back to the position number 1. So we're going to select position register number 2, and we're going to move to that position. So now we're going to select the multi-view vision process. We're going to go to edit. We're going to select the parent tool. And on this, we're going to select the offset mode. It's going to be the fixed frame offset. Offset frame, we're going to select the user frame number 1, and we are not going to log any data. Now we're going to have 2 camera views. We're going to have camera view 1, and we're going to have camera view 2. We're going to select camera view 1. The camera is going to be the camera 1. Part Z high is going to be 0. And we're going to select the snap tool. We're not going to make any changes over here. We're going to select the GPM locator tool, and on this case we need to just take a snap, and we're going to teach the positioning here, and I already did that. And also I set the origin. As you can see here, I trained the mask, and also the other thing I did, I select the scale and the aspect ratio on the degree of freedom. So one thing that we can do, we can take a snap and find and see if we can find the part. In this case, was able to find one part in there. So now we're going to select camera view number 2. We're going to move the robot to that position. We're going to select the position register number 4, and we're going to move to the location. And now on the parent tool, we're going to select the camera. It's going to be camera number 1. The part C height is going to be 0. On the snap tool, we're not going to make any changes. On the GPM locator tool, we're going to take a snap, and we're going to teach the GPM, and we're going to set the origin. The other thing we're going to do is exactly the same way we did before. We're going to select the scale and the aspect ratio for the degree of freedom. We're going to take a snap and find, and in this case it found 2 parts. So one thing that we can do, we can change the reduce the orientation. We can select something like a -10 and +10 degrees and see that helps. We're going to take another snap and find, and in this case it found only 1 part. So now we're going to go to the offset area calculation tool, and we're going to take only a find, and we're going to set the reference position status. At this point we can just save and end the edit. and we go back to the work result. So now we're ready to test the program. We're going to select the program, and here is going to be the main. Something that you're going to notice that in the Vision Run instruction, there is something new that now is showing camera view number 1. The way that you're going to get this one is going to be if you select the instruction, go to Vision, we're going to select Run Fine, we're going to select the multi-view vision process, and we're going to go to Choice, we're going to select camera view, and we're going to select camera view number 1. We're going to have two camera views. We're going to do the Run Fine for camera view number 1, and then we're going to move to the second position, and we're going to do the Run Fine for camera view number 2. And then we're going to get the offset, and we're going to put it on the vision register number 1 as usual. Something that you need to know is that you can run this one either first camera view number 1 and then camera view number 2, or you can do the other way around. You can run first the camera view number 2 and then camera view number 1. There is not going to make any difference. What is going to make a difference is you have 4 camera views. In the case you have 4 cameras, and as I mentioned in the previous video, you cannot mess up the order. Either you're going to go clockwise or you're going to go counterclockwise. So if you had camera 1, camera 2, 3, and 4, you need to go in order for camera view number 1, then camera view number 2, camera view number 3, and camera view number 4, or you can go in the opposite order, but you cannot trigger camera view 1 and then camera view 3 and then camera view 2 and then camera view 4, and that is not gonna work. So we're gonna run the program in step mode. We're gonna start going to the home position. We're gonna go to the camera view number 1. We're gonna run the vision process, and then we're gonna move to the second position. Also notice that I have a wait instruction in here to make sure that the camera doesn't shake while the robot is still moving. We're gonna run the second fine position for camera view number 2, and now we're gonna get the vision offset. So for that, we're gonna select the data, vision register, and vision register number 1. So we get the offset in this case, because we are in the reference position, we're gonna get an offset of 0. And now we're gonna move to the bounce position. We're gonna pick up the part. At this point, what I'm gonna do, I'm gonna show the part on the gripper. And now we're gonna go to the place location. What we're going to do now, we're going to change the position for the part, and we're going to put an offset similar to the one that we have in the previous video. Let's see if we can run the program in simulation mode. And I'm going to pause the program while it's picking it up. You can see here that it moved to the new offset, and if we look at the offset, we have this value over here. Let's continue running the program. Now we're going to go to the place position. And the program was able to get the right offsets using just one camera. Let's move now to the second part of the video. We're going to do the configuration for the tool offset with two fixed cameras. In this case, the offset frame is going to be a tool frame. We're going to use the same word salad that we have in the previous video, and we're going to rename it. In this case, we're going to have a user tool number 1. That's going to be our gripper. We're going to have a user tool number 2. That's going to be the calibration grid frame. And we're going to have the user frame number 1 for the peak position and a user frame number 2 for the place position. We're going to start making a change to the user tool number 1, and we're going to change the orientation. If we look at tool number 1, the orientation as I'm showing here. And if we compare this one with the previous video, when we select the tool number 1, the z-axis is pointing down, and in our case, the z-axis is pointing up. You're going to see in a moment why we are doing this. Now we need to select the user tool number 2, and for that, the user tool number 2 is going to be our calibration grid frame setting, and we're going to install the calibration grid on this user tool. Something that we're going to do, we're going to copy the user tool number 1 on the user tool number 2. The way that you can do that, if we go to the teach pendant, I have in here a EP program, and what this is doing is taking the user tool number 1, it's going to put in a position register number 10, and then we're going to move the position register number 10 to the user tool number 2. So when you run the program, what this is doing is just copying the user tool to user tool number 2. So now if we select user tool number 2, we're going to be in exactly the same position as we have for the user tool number 1. Next thing, we need to set the calibration grid frame setting, and we're going to use the automatic setting for that. And we need to position the calibration grid under the camera number 1. Doing that is going to be a little tricky. What I have in here, have the position register for the home. I have a position register number 2 for the camera 1 position 1, but you're going to see if I try to move to that position, let's do a shift move to, we're going to have a position configuration change because the A6 number 5 is going to be tilted up. So we're going to move the axis number 5 and we're going to move it up this way. And now we should be able to go to the position register number 2. We're going to crash on the frame for the camera, but we are in Robot Guy. So now we have the calibration grid frame on the field of view of the camera 1. And we're going to select over here, we're going to go to menu, we're going to go to iRVision, we're going to go to Vision Utilities, and we're going to select the, if we are not there, we're going to select the automatic green frame setting. We're going to go to details, and we're going to select, in this case, user tool instead of user frame. So we're going to go step by step. We have the robot group number is going to be group number 1. For the user frame or user tool, we're going to select user tool. The tool frame is going to be number 2. We're going to select the camera number 1. If we go to choice, we have camera 1 and camera 2. And then we're going to select the start position. We're going to use the position that we have right now. So we're going to select shift record. And now we're going to go to step number 7. That's going to be the grid spacing. That's going to be 15 millimeters. We're going to do an execute. We're going to take it off from step mode. And we're going to reduce the speed to something like 30%. We're going to press shift and execute. It's going to take some time because we're going very slow. And you might also notice that probably we're going to crash on the frame for the camera. So if that's the case, you can just adjust the position. So now finished, we're going to press OK. And we have the result over here, and we can go to menu, setup, frames, and we're going to have a result for the calibration grid. You're going to notice something here that if we look at the shift coordinates, now it changed to tool number 2. And if we look at the tool frame, we're going to select the user tool number 2. And we're going to look at the position. It changed the coordinates from the one that we have for user tool number 1. Our new user tool is going to be on this position over here, on the center of the calibration grid. And also we have the orientation with the XY on the plane of the calibration grid and the Z axis pointed out. So that's the reason why originally we moved the orientation for the user tool number 1 to the Z pointing out just to match the user tool number 2. If you read the manual what it says is that once you do the calibration for the grid, you need to copy the user tool number 2 to user tool number 1. And the idea for that is that you want to match the orientation of the user tool. In this case, I did the all the way around. Just started with the user tool number 1, changing the orientation to match the user tool number 2. If the user tool number 1 doesn't match the orientation for the calibration grid, when you run the vision process, you're going to get a fault that says camera tilted too much, and you're not going to know why. So now what we're going to do, we're going to record again the position register number 2. In this case, we're going to do override with the user tool number 2. Originally was recorded with the user tool number 1. And we're going to do the same for the position register number 3. Shift record, position register number 4. and position register number 5. So position register number 4 and number 5 is going to be for camera number 2. We're going to change the positions. If you look at the position register number 2, we're going to have on the Z-axis 170 millimeters. So we're going to select position register number 3, and we're going to change the Z-axis to 217 millimeters. Now we need to change the position for the position register number 4 and number 5. We need to know how far is the camera number 2 from camera number 1. For that, we're going to use the measurement tool. And we're going to go from camera 1 to camera 2. And it's showing that the distance is 882 millimeters. So we're going to select position register number 4. And on the axis, we're going to add 882 millimeters. It's going to be 2444. And also, we're going to change the position for the position register number 5. Now, we're going to verify the positions. We're going to move to position register number 2. We're going to move to position register number 3. It's going to be 100 millimeters up. We're going to move to position register number 4. It's going to be on camera view 2. And we're going to move to position register number 5. So now we are ready to start with the camera view. We're going to select robot. We're going to select Internet Explorer. We're going to go to iRVision and Vision Setup. And here I have already the camera data for camera 1 and camera 2. And we're going to go over this configuration. We're going to select camera 1. We're going to go to Edit. On the camera setup, we're going to select the camera 1. On the robot mounted camera, we're going to select No. And the calibration, we're going to select grid parent calibration. Calibration setup, we're going to select the application frame. It's going to be user frame number 0. Grid spacing is going to be 15 millimeters. Robot calibration grid, we're going to select yes. And the robot holding the grid is going to be this robot on group number 1. The setting calibration grid position method is going to be use frame. Calibration grid location, we're going to select the calibration grid frame. In this case, it's going to be user tool number 2. And we're going to do a snap. And we're going to set the calibration position status. Then we're going to select calibration, and we're going to use the number of planes is going to be 2. So we are already in position 1 for camera number 1. We're going to press find 1 for the first plane. And then we need to move the robot to the second position. So we're going to select position register number 3, and we're going to move to that position. And now we're going to select snap, and we're going to find the second plane. Once that is done, we're going to go to the calibration points. We're going to review the points for plane 1 and plane 2. We're going to go to the calibration result. We're going to save and we're going to end the edit. The procedure for camera data on the camera number 2 is exactly the same. We're going to select, in this case, camera number 2. And what we need to do, we need to move the robot to that position. So we're going to go to position register number 4. We're going to do all the same procedure that we did before. And in this case, we're going to select the number of planes going to be 2. This is going to be the first plane, so we're going to press find 1. And then we're going to move the robot to the second position. That's going to be position register number 5. And we're going to find the second plane. Then we're going to have the calibration points and the calibration result. We're going to save and we're going to end the edit. Now we're going to move to the vision process. We're going to select the 2D multi-view vision process. We're going to go to edit. And what we need to do now, we need to pick up the part. So we're going to go back to the work cell. And I'm going to use a program that I already have. So we're going to press select. And I'm going to select the main program. We're going to go step by step. We're going to move to home. We're going to move to the bounce position. We're going to pick up the part. And I'm going to simulate that I have the part pick up. We're going to go to the retreat position. And now we're going to go to the vision position. So notice now that we have the part of the same height as we have for the calibration grid. So the Z part height is going to be 0. At this point, we're going to go back to the vision process. We're going to select the parent tool, and the offset mode is going to be tool offset. The robot holding the part is going to be group number 1. Offset frame is going to be user tool number 1, and we are not going to log any data. We're going to have again camera view number 1 and camera view number 2. We're going to select camera view number 1. We're going to take a snap. And here we have the first part. So we're going to select camera. It's going to be camera number 1. Part Z high is going to be 0. We're going to select the snap tool. We're not going to make any changes over here. We're going to select the GPM locator tool number 1, and we're going to teach this position, and we're going to set the origin. Also, for the degrees of freedom, we're going to select the scale, the aspect ratio, and the orientation. I'm going to go from -10 degrees to +10 degrees to make sure that we are only finding one part instead of 2 parts. We're going to do a snap and find, and we were able to find one part. So now we're going to move to camera view number 2. We're going to take a snap. We're going to select for camera number 2. On the snap tool, we're not going to make any changes. We're going to go to the GPM locator tool number 2. We're going to teach the GPM with the set orientation, and for the degree of freedom, we're going to do exactly the same. We're going to go from minus 10 degrees to plus 10 degrees, and we're going to do snap and find, and we were able to find the part. So now we're going to select the offset data calculation tool. We're going to do a find, and we're going to set the reference position status. When we're done, we're going to press save, and we're going to end the edit. So now we're going to go back to the work cell, and what we're going to do, we're going to place a part on the place position. We're going to select over here the data. We're going to select the vision registers, and we're going to select vision register number 1. Now we're going to start moving forward. We're going to call the vision process. We're going to call the run find the multi-view vision process, and we're going to get the offset. In this case, the offset is 0 because it's our reference position. Next step, we're going to move to the place position. We're going to go to the approach position, and we're going to call the place program. Notice that in here is where we're going to put the offset for the vision process with the vision register number 1. And we place a part, and we move back to the home position. Okay, what we're going to do now, we're going to do a offset for the part. So first, we're going to pick up the part, and then we're going to move it once we have on the gripper. We're going to go to the vision position, and before we run the vision process, we're going to move the part. We're going to move the part to make sure that still we are inside the field of view for the GPM locator 1 and GPM locator 2, and we move like 3 degrees. So we're going to keep running the program. We got the offset, and now we're going to place the part. Now we are in the place program, and we're going to apply the offset. And you can see that we are aligned with the locator pins. In conclusion, I show you the three configurations for the 2D multi-view vision process. For the fixed frame offset with a fixed camera, the calibration grid frame and the offset frame are both user frames, and we're going to need two calibration grid frames, one for each camera. For the fixed frame offset with a row mounted camera, again, the calibration grid frame and the offset frame are both user frames. In this case, we only need one calibration grid frame because we have only one camera. And when we call the vision run find, we need to add the camera view number to the instruction. This is a way that iRVision is going to know the position of the camera. For the tool offset with a fixed camera, the calibration grid frame and the offset frame are both tool frames, and we're going to need only one calibration grid frame. We saw that in all the cases we follow the same workflow. We start defining the user tool and user frame, we set the calibration grid frame, and then we configure the camera data and the vision process. Finally, I'm going to leave the link to the work cell on the description below, and thank you for watching.